In this video we are looking at special angles, right? And special angles are angles of the form 30, 60 and 45 degrees. These are 30 degrees, 45 degrees and 60 degrees, right? So I'm not talking about angles like 90, 180, 270 and 360 and 0. Those are angles that require you to use trigonometric graphs or to just plug it in your calculator and then work it out. But I want to talk about three different three angles that refer to special angles. Now, one of the ways that we can actually construct the triangle to speak about special angles is to take an equilateral triangle. Now, you know an equilateral triangle is a triangle in which all three sides are equal, right? And I'm going to consider this third side also to be of length 2. But if I were to cut an equilateral triangle in such a way that I break it down there right in the middle, right? Then I'm going to be dividing it in such a way that that side over there is going to be 1. This here is going to be 90 degrees and this is going to be 90 degrees. Now, as you know, the sum of angles in a triangle adds up to 180 degrees. In an equilateral triangle, that's 60. This is 60. This is also 60. So this is 60 degrees. But seeing that I cut this 60 degrees in half, that's going to be 30 degrees, right? Okay, so now I know I can use Pythagoras to find the length of the third side. That third side, if this is length 1, and this is also length 1, right, from there to there, there to there, that entire length is 2, but I cut it in half, so I got 1 and 1. This side is 2. That means this side is going to be the square root of 2 squared, which is 4 minus 1. And that gives me that length as root 3. So that's the first special triangle I get. I get a triangle that looks like such, and I've got angles 60 degrees, 30 degrees, right angle over there, and I've got three lengths. This length is 2, this length is 1, and this length is the square root of 3. Now from there I can read off, because they're the special angles, I can read them off from this triangle. And now I can find certain values. For example, sine of 30. And you're going to say, well, Imad, sine of 30 is just going to be, take 30. What's opposite 30? It's 1. And that's 2, so that's going to be a half, right? And then I can say, well, okay, what is sine of 60 degrees? Sine of 60 degrees. Imad, 60 is over here, and opposite that is root 3 divided by 2, and that's root 3 over 2, right? What about sine of, well, just what about cos? Let's look at cos, right? Cos of 30. Cos of 30 is going to be, cos is there, 30 is over there, cos is adjacent, which is going to be the side that's next to 30, which is root 3 divided by that side over there, which is going to be 2. And then finally, let's look at one more and say, what about cos of 60 degrees? Cos of 60 degrees. Cos of 60 degrees is just going to be 60, adjacent is 1, and the hypotenuse is 2. Remember, the hypotenuse is always the side opposite the right angle. Okay. Now you can say, Imad, I see a pattern. I see that sine 30 is equal to a half, but so is cos 60. And I also see that sine 60 is root 3 over 2, and so is cos 30. Well, that's actually something new. That's actually called co-ratios or co-functions, right? That's called co-ratios or co-functions. Now, whilst we're in this video, I might as well tell you what co-functions are. Co-functions, and you've seen where we've applied this already. You've seen me introduce you to it. I said 90 minus theta and 90 plus theta and 270 minus theta. Oh, sorry, this side is plus theta and this side is 270 minus theta. These are the identities for co-functions or co-ratios. So for example, here, if I go one back, you can see very clearly, you can see it very, very clearly. Sine 30 is equal to cos 60. Sine 30 is equal to a half. But so is cos of 60 degrees. is also equal to a half. That's very important. Now you can determine a pattern even if we don't know the exact values of some ratios. We can say that sine of 90 minus theta is equal to cos of theta. You just take that and you plug it in on that side. That goes there. And a perfect example is the one you've just seen. Sine of 90 minus 30 is equal to cos of 30. And that means that sine of 60 is equal to cos of 30 degrees. And if we go one back, we can see that sine 60 is root 3 over 2. And cos 30 is also root 3 over 2. So therefore, that's called a cofunction, root 3 over 2. And we can literally do this for anything. We can do it for any identity, right? It becomes a little bit more tricky when I look at 90 plus theta and 270 minus theta and 270 plus theta. But I think I'll do that in the next video where we look at some of the other identities over here. Okay, so that's your first set of special angles. This is some cofunctions and co-ratios over here, just the first set, doing the first quadrant 90 minus 30. And let's look at one more triangle where we can speak of special angles. Well, the other one is going to be, if I take a triangle, and this one is a right triangle, because remember they've got to be right. No. We will draw it straight lines as such. Okay, I'm going to make it a little bit smaller so that we can preserve the lengths. Okay, I'm going to say this is length 1, this is length 1. Now remember, if the lengths are equivalent, the angles opposite the sides will also be equivalent, which means this side will equal that side, which means this angle must equal that angle. So if this is a right angle triangle, the remaining angles are 45 degrees each. Now remember, what do I call a triangle in which two sides are equivalent? Right? I call it an isosceles triangle. This is an isosceles triangle. So this is 45 degrees and this is 45 degrees. Let's just get that a little bit clear. Right? And this here, Pythagoras tells me this is equal to the square root of that squared, which is 1, plus this squared, which is 1 plus 1, which is root 2. Now these are the sine of 45 degrees. Well, opposite 45 is going to be 1, and the hypotenuse is root 2. Now, did you know that 1 over root 2 is equal to root 2 over 2? This is called a rationalized denominator form of this over here. And how do I get that? This is just an aside. Let me give you the aside. I say 1 over root 2 multiplied by root 2 over root 2. Now how I multiply fractions is the top times the top and the bottom times the bottom. So this is just going to be root 2 over root 2 times root 2 is just root 2 squared, which is just root 2 over root 2. And remember, this thing is just equal to 1. So I'm multiplying it by 1, and that's how I get that over there. Okay, so sine of 45 is 1 over root 2. What about cos 45? Now you can say, well, Imad, cos 45 is equal to sine 45 without even looking at the diagram, because these are co-ratios. Like you saw over here, 30 and 60 add up to 90. So 45 plus 45 add up to 90. And in other examples, co-ratios, sine of 30 is equal to cos of 60 degrees. What about cos of 25? That is equal to sine of 65 degrees. What about sine of 18 degrees? That is equal to cos of 72 degrees. All of those are examples of co-ratios or co-functions. Right, and there we go. Introduction to special angles 30, 45, and 60. Ignoring this triangle over here and using this triangle. But if you're having difficulty to come up with this triangle, use the equilateral triangle to come up with this one. Okay, and then you can determine your special angles. And then similarly, we introduced you to co-functions or co-ratios that add up, that use this identity, sine of 90 minus theta, sine of 90 minus theta, cos of 90 minus theta, and how we just plug it in on that side to get that over there. Okay, and this is how it looks. And that's the last one over there, where we have a special angles using this triangle with sides 1, 1, and root 2, with the angles being 45 and 45 degrees. Okay, in the next videos we will start looking at the solutions, and then also some more intricate co-functions.